Here's the graph of y equals g of 0.5x. So again, we notice that this 0.5 is inside the function. Okay? That's going to be a vertical, no, not vertical, horizontal stretch. We're going to multiply our x values by, now 0.5 is 1/2. Do you remember from yesterday, everything inside was the reciprocal? So we're going to multiply our x values by 2. So on our original graph, we have -3, 2. If you multiply your x value by 2, you're going to get -6, 2. The scale here, you got to be careful. The x's are going by 2s. So this point up here is 1, 5. Multiplying your x value by 2, you're going to get 2, 5. Here we have 3, 3. So that becomes 6, 3. And finally, this one is 4, -2. We are now going to get 8, -2. Connect the dots as best as you can. And you have stretched it horizontally. So when you think of something being stretched horizontally, it's like you grab a hold of it on either side of your y-axis, and it gets pulled away from that y-axis. When things are compressed, they get squished towards the y-axis. So this red graph, can you see it was sort of grabbed on and pulled out? And so we would call that a horizontal stretch by a factor of 2. State the domain and range of each one. Domain are x values. I'm going to use set notation this time. The x values, the smallest x value is -3. The largest x value is 4. The range, the smallest y value is -2, and the largest y value is 5. Then for the blue graph, the domain now goes from 6 to 8, and the range still -2 to 5. Does it make sense that the range didn't change? If we think about the only thing that we did is we multiplied our x values by 2, that's going to change your domain. Can you see how the domain got changed? -3 to 4 to -6 to 8. Can you see that multiplying by 2 happening in there? But your range didn't change. Questions for practice on this one are 4 and 8.